how we would find the perpendicular bisector between 2 points 3, 4 and 9, 6. The first thing I'm going to do is identify where 3, 4 and 9, 6 are on the diagram. 3, 4, and then finally 9, 6. So a perpendicular bisector is a line which cuts this line exactly into two and is perpendicular to this line. So there's a series of different steps we need to do, which we're going to work out step by step. The first thing you need to do is work out the midpoint. Now, you may be expected to work out the midpoint algebraically or using the visual diagram. Visually, you can see that the midpoint is quite easy to calculate. This is because the midpoint is identified as here. This is because it's halfway in between 3 and 9, which is 6, and halfway in between 4 and 6, which is 5. The next thing you'd have to do would be to calculate the gradient of the perpendicular bisector. Now, the way we would do this is calculate the gradient of the current picture. The way we have a look at that, we can see that for every 1 we go up, we go 3 across. And because the gradient is the change in y, which is 1 divided by the change in x, the gradient is going to be 1/3. Let's show you how you do this manually. So the first thing we calculated was the midpoint. The midpoint, the way you calculate this using a manual equation is adding the x coordinates together, then dividing it by 2, and then simply doing the same with the y coordinates, adding them together, and then dividing by 2. Remember, there may be some questions in the exam where you're given one of the blue dots, one of the red dots, and you have to calculate the next blue dot. So then you'll have to sort of fill in the missing gaps. This then would be 6, 5. Easy. Next thing we're going to do is work out the gradient of the line. We've done that drawing on the picture, but you can do it manually. You do the difference in y, 6 minus 4, divided by the difference in x, 9 minus 3, which is going to be 2 divided by 6, or 1/3. Now we're going to do the gradient of the perpendicular bisector. Remember, if something's perpendicular, you flip it and you change the sign. So 1/3 flipped becomes -3. Now let's show you and everyone else in the class how to do this on the picture. So instead of going up 1 and 3 across, we're going to go up 3 and 1 across. Or down 3 and 1 across. Down 3 and 1 across, etc. So this would be the equation of our perpendicular bisector, but we actually need to calculate what the equation is. We've got the gradient, excellent, but we don't have the y-intercept. Now, remember when we're trying to calculate the y-intercept, you could either continue drawing it, but this would not work for this example because the drawing would go off the picture, or alternatively, you could calculate it manually. And we've done this lots since the beginning of D1. We would write y equals mx plus c. This time it's minus 3x plus c. And then we're going to substitute any coordinate, x and y coordinate, into this formula. The one that makes sense is to substitute the midpoint coordinate, which is 6, 5. So whenever we've got a 5, we're going to replace it with y. And then whenever we've got an x, we're going to replace it with 6. Then we're going to have c is equal to 23, one of my favourite numbers. Last but not least, we are going to combine the 23 and the minus 3 into an equation. So the equation of the perpendicular bisector is y equals minus 3x plus 23. If, for example, the question also asks you to find the equation of the original line joining these 2 points, that is just as simple. I'm going to show you a slightly different way of doing this. I'm going to extend this line because we would know it's got a gradient of 1/3. The next point would be here, and we can see visually that the y-intercept is 3. So this equation of this line would be y equals 1/3 x plus c, which is 3. Just to recap, we were given 2 points and asked to find the perpendicular bisector, which is a line that cuts the line that joins these 2 points in half. To find that, first of all, you find the midpoint. That's a coordinate. Once you found the midpoint, you then need to find the gradient of the original line. That will then help you find the gradient of the new blue line. Once you found the gradient of the new blue line, you now need to find the y-intercept of the new blue line. You either do that through drawing or you do that through substitution, which we did. And in the exam, they may also ask you to find the equation of the original line, and the way we did that was through drawing. We continued the line, found the y-intercept was 3, and we'd already originally found that the gradient was 1/3, and we combined them all together.